Imagine approaching a bridge. As you get closer, you anticipate the other side. Limits in calculus work similarly. We analyze a function's behavior as it gets closer and closer to a specific point, even if it's undefined there. Think of a function like a map. A limit tells us where we'd end up on our journey, even if the destination itself is marked off. We might encounter a detour or a roadblock, but the limit reveals the intended endpoint. This concept is crucial when dealing with functions that have gaps or jumps in their graphs. By examining their behavior as they approach these points, we gain valuable insights into their overall nature. Limits help us understand what happens at the edge of the known. Approaching that bridge from opposite directions might reveal different perspectives. Similarly, in calculus, it's crucial to check both sides of a limit. This means examining a function's behavior as it approaches a point from both the left and right. Why is this important? Consider a function with a break in its graph. Approaching the breakpoint from the left might yield a different value than approaching it from the right. This difference indicates that the function doesn't approach a single well-defined value at that point. The limit doesn't exist. However, by examining both sides, we gain a complete understanding of the function's behavior near this point. We can see if it approaches different values or behaves consistently. Infinity, a concept that stretches beyond our grasp. In calculus, we use limits to explore the behavior of functions as their inputs or outputs head towards infinitely large values. Imagine a rocket launching into space. As it travels farther from Earth, its velocity might approach a certain value. This is a limit at infinity. We're analyzing the function's behavior as it ventures into the unbounded. Remember, infinity isn't a number, it's an idea. We can't plug it into equations like we do with regular numbers. Instead, limits provide a framework for understanding how functions behave as they approach these boundless realms. Section 4. Unlocking limits, methods for finding solutions. While visualizing a function's graph can provide some intuition about its limits, we need more precise methods for determining them algebraically. Calculus offers several techniques, each with its strengths. One common method is direct substitution. We simply substitute the value that the variable approaches into the function. However, this only works if the function is well behaved at that point. Factoring is another useful tool. Sometimes we can simplify a function's expression to cancel out terms that might be causing it to be undefined. This allows us to evaluate the limit more easily. Algebraic manipulation provides even more options. We can use algebraic rules to rewrite the function in a form that makes the limit easier to determine. This might involve rationalizing denominators or using trigonometric identities. Section 5, the foundation of calculus, limits enduring significance. Limits are not just a theoretical concept in calculus, they form the bedrock of its most important ideas. Without limits, we couldn't define derivatives or integrals, the cornerstones of calculus. Derivatives, which measure a function's rate of change, are defined using limits. They tell us how much a function's output changes with respect to its input. Integrals, on the other hand, calculate the area under a curve, and they too rely on the concept of limits. By understanding limits, we gain a deeper appreciation for the interconnectedness of calculus concepts. We see how this fundamental idea underpins the tools we use to model change, analyze motion, and solve complex problems. Section 6. Conclusion. Limits as a gateway to calculus. Limits are the gateway to understanding the intricacies of calculus. They provide a language for describing the behavior of functions at their edges, near infinity and everywhere in between. By mastering limits, we unlock the power of calculus and its ability to model the world around us. From the smallest particles to the largest structures in the universe, calculus, fueled by limits, helps us make sense of the patterns and relationships that govern our reality. So embrace the challenge of understanding limits, for they hold the key to unlocking a world of mathematical wonder.